Hello, everyone. Welcome to today's Seagrass webinar number 2. My name is Gustav Kegesten. I'm the Science Director of Hub Ocean. With me, I have my colleague Brian Free, spatial ecologist, and Lina Mtwana Nordlund, who will be presenting with us today. And we'll take a couple of, we'll wait another minute to let people sign in. So feel free to say hello to friends you see or just stand by, and we will get started in earnest in just a bit. Okay, I think we slowly get started. So what you got yourself signed up for today is an hour where we will be talking about seagrass data, and with focusing on sort of maps and information from global to local scales. And this is the second webinar that we're actually hosting today. If we look a bit fatigued, we did a same kind of webinar with Chris Rolfsma from Australia earlier this morning. It will also be recorded if you want to check that. The presentation from Chris. Since then, we've been hard at work to update some data layers, and hopefully we'll bring in some more flavor for those that are joining us twice. And a bit of how the flow will go. I'm going to do a short introduction about Hub Ocean first, who we are, and then we will hand over to Lina and hear about her work on seagrass, and then we will move on to a live demo of the ocean data platform, and it has essentially 3 components. We will have a look at what the platform is and what's in the catalog when we are especially focusing on seagrass data. Then we will move into how to actually upload new data into the platform, and my colleague Brian will show you a bit of what we have done for these webinars to bring in more seagrass data, and also hopefully inspire you that you can do the same thing for other similar tasks on Ocean Data Platform. Then we move into a little bit of a demo of how you can bring maps together using some of the compute functionalities of the platform. So it goes a little bit technical. We'll be scrolling through some code. We will be generating some maps, and hopefully that will serve as some inspiration at the very least. And then we'll end up with the Q&A and some short questions. And feel free to put questions in the chat during the whole talk, and then we will try to make room for verbal questions by the end. All right, Hub Ocean, we are a nonprofit based out of Norway, and we are building the ocean data platform. It really got started because our sister company, Rev Ocean, are building a state-of-the-art research vessel that will be operational starting next year. And we were essentially built to be the data hub for Rev, but as years gone by, we have really focusing on this, bringing global ocean data onto a very efficient platform, and I'll move over. And you'll get to see more of that. Who's on the platform? Yeah, you can see Norway has a good representation per capita, but we really are trying to reach as many global users as we can, and I think we have a fairly good representation around the globe. So the Ocean Data Platform really is our shiny beast in the middle, and it has the main component of an open data catalog where we are putting as much useful data as we can, what may it be open public data or data that we try to unlock from example industry data. We are pushing industries to share more data back to science as one of our sort of legs. It also has your own data space, and we'll get to see more of that. If you sign up, which is free, you can have access to your own space, and you can follow along and access all the data that I'm showing. The platform is also built to be a backend, so it has a powerful API that you can connect to from websites and apps. We have our workspaces, but really you can work with the platform from both local and other workspace environments in the cloud. And we have a JS integration piece that we're not showing in depth today, but we have good documentation on the platform. So you find the platform on app.hubocean.earth, and you can use that QR code if you quickly want to access it now. And by that, I will actually hand over to you, Lina, to talk about Seagrass before we go into the weeds of the platform.
Thank you so much, Gustav. Let me see if I can do this. Are you seeing the presentation?
We are.
Fantastic. Okay, so my name is Lina Mtwana Nordlund, and I work at the Uppsala University in Sweden. And I'm also on the bioeco panel for the Global Ocean Observing System, leading the Seagrass Essential Ocean Variable. I do recognize a lot of names of participants, which is really nice to see a nice part of the seagrass community joining us. Seagrasses are, I think, really amazing plants that grows almost around the world, except around the South Pole. And I think the links between the ecosystem of seagrass and human well-being are very strong. We see a lot of ecosystem services, for example, when it comes to food provisioning, but also to protect our shorelines. And I mean, look at this. I mean, who doesn't want to go and snorkel in a meadow like this? But to better understand our seagrass, we need to observe them, we need to measure, we need to count, we need to monitor. And I mean, if we could work better together and we had more comparable data, we could really advance our understanding. And one concept called the essential variables, they have been developed because it's just not possible to measure everything at all times, because it's just too expensive and too time consuming. So there's a lot of different essential variables, but I will talk about the essential ocean variables. And the essential ocean variables are governed by GOOS, the Global Ocean Observing System. You can scan the code there if you want to read a quite newly published paper about sort of the background of GOOS, essential ocean variables. But these EOVs, or essential ocean variables, are a minimum set of key ocean measurements that are required to systemically assess the state of the ocean. So they have been selected on the basis that they can actually be very informative to understand our oceans. And we have 36 essential ocean variables, and one of them is the seagrass. And each essential ocean variable has a specification sheet, and these specification sheets are almost like recipes on how to measure. These specification sheets has the background, justification, the applications, the phenomena to observe, the EUV observing specifications, the data management, and also observing approaches. And I will actually go through a little bit about these EUV specification sheets, because it's important that we do measure things, and we do measure things that are comparable. So seagrass is one of these essential ocean variables. And at GOOS, the Global Ocean Observing System, on the bioeco panel, it's myself and Dimitris Protosanidis that are leading this. So if you're also interested in learning more about the seagrass EOV, you're very welcome to contact us. And there's, of course, people around the globe that have provided input. We are just in the process of updating the specification sheets again. They will be published basically within a month, and it has just gone through 3 global open reviews. So, as I said, these specification sheets are almost like recipes. It describes the EOV, the background, the justification. It provides information. And here, with the arrow, you can see the EOV subvariables. These are actually the sort of the key measurements that you measure that make up the essential ocean variable. And for seagrass, these are seagrass percent cover, seagrass species composition, and seagrass areal extent. Of course, there are many other very important variables, but as a global community, we have sort of agreed that these 3 are really the minimum, or the really the key ones that we should start to measure and publish the data for. So, and I think many of us were already measuring maybe either areal extent or percent cover or species composition. In the spec sheet, there is also guidance on supporting variables. We have both environmental variables, water depth, water clarity, I think are variables that are often measured, but there's other suggestions here as well. This doesn't mean that this is the only variables to measure, but these suggestions that many think are relevant for seagrass. There's also supporting variables related to the seagrass EOV, for example, seagrass shoot density, which many are also measuring. So that is something that you then can complement the subvariables with. In the specification sheets, we're also presenting the phenomena to observe, and the 3 for seagrass is habitat status and trends, and then another example is changes in species composition. It's also presenting the sort of the specifications or the requirements. Here is sort of the ideal way of measuring seagrass, and it provides references on how that can be done. And it also provides sort of a minimum of how to measure the different subvariables. It also presents observing approaches with references of sort of suggestions on how to measure the EOV. It also has a data and information management section. We have also developed a data schema where it's a really structured way of how to submit the data so it becomes available and usable for others, following then FAIR principles. In the Bioeco Ocean project, together with OBIS, the Ocean Biodiversity Information System, we've also developed a EOV metadata app to really facilitate publishing data. So if you want to learn a little bit more about the seagrass EOV, you can read a newly published paper led by Emmett Duffy. So he was the lead for the seagrass EOV before myself. I will also post all of these things in the link. There is also webinars around the seagrass EOV that you could look into. So why am I bringing up this EOV? Because the EOV is really a good and structured way of submitting data or publishing data in a structured way. And imagine if we are all publishing our data, there will be a very nice abundance of data in the digital ecosystem. And with more available data, we will be able to do really cool data products. One product that requires a lot of information is, for example, mapping. And to do, for example, seagrass distribution maps. This slide is prepared by Chris Rolsema, and he showed it this morning. And I kidnapped it because I think it's really good, showing that there's a lot of work going into actually doing really good distribution maps, and you need to have complementary knowledge. And field data is actually also very, very important to verify what you're doing. So I think what I really want to say is that it's really key about the data, where we publish, how we publish, and what we publish. So we need to contribute that to the digital ecosystem, following FAIR principles, because then this data is becoming available. And as Gustav and Brian will soon show us, is that when there is a lot of data available, you can do some really cool stuff. So I'm very excited to see. I also participated this morning, and to see what they actually also added now during the day. So it's very fast evolving, which is super cool. So it's really about going with the flow, using standardized protocols, collecting the data that you need, but also publish the data. Because the more published data we have available, the better products we can do, and the more benefits. So collaboration, especially when you then have data platforms where you can visualize all this different data, can really advance our understanding of the ocean. And there is cool things that could be developed, for example, early signals or early warning systems. And also when we are measuring similar or the same way, and publishing the data across borders, we can also really learn more on what's happening and learning from each other. A little bit of a side note, because it's really important that we collaborate. I just wanted to share a product that we are developing in the BioEco-Ocean project, where I'm the project coordinator. We are developing a general operational framework called Oceanis. And it's a question-based support tool, and it's there to spark and encourage collaboration and support communication across the sectors, and really to advance or to support integration. And I think when it comes to, for example, here with the Hub Ocean, you will soon see this My Data space. So how do we do the best things, and how do we collaborate, and how do we plan what kind of data to add, and maybe what data we need to collect? And I think this is a very, very nice tool. It's still in development, but we have published a quick start guide that is possible to download. But the framework is basically a spider web in the middle. It's really showing the connections between a lot of different components. So the data products are, for example, things that you can develop in with the Hub Oceans help, and also think what to think about when it comes to maybe harvesting data. And the framework is more than just a spider web. It also has descriptive words and themes, and they're combined with question words that can really help you to think much deeper and much more interconnected. So I will share also the link to this quick start guide. But that's all for me, and I'm really excited about seeing more about the data. And for me personally, I think this My Data space is extremely interesting, because especially me working a lot also with research, that you might have data that you cannot publish yet, but you will do soon, but you can still work on it in that space. So thank you.
Thank you very much, Lina, for showing your work and for yeah, already thinking a bit how we fit into this picture. And so I will we'll go back to the live demo. We will struggle a bit on time. Don't worry if you feel it's going a bit fast. We will also provide a recording, and there'll be many more ways to sort of dive deeper into what can be done here. So I hope what comes next serves more than inspiration than anything. So anyway, if you want to read more about us, you can zoom over to our webpage. There's an about and FAQ session. But let's dive into the platform. And maybe I make a first comment also. So what we have here is an open data catalog with assortment of data. We were just about to dive in, and we try to make it, include useful data across environmental variables, across human use, data, and ecosystems, habitats, and species. But we're not covering the whole. Well, we don't have all the data on the in the ocean, and I don't think we will ever be close to being, the one-stop shop. You will always need to bring in data from other places or from our platform if it has the original data. That's what FAIR is about, right, Lina? I think, and then we have the My Data space we'll have a look at, where you can use the same fast API technology as we are in the catalog, and you can also publish to the catalog. And then we have the workspace. There is a good documentation page. I will flip over to it in a bit. Support functionality and a Slack community as well. Okay, so really this catalog, it's built to be very fast for geospatial data, and we've spent quite a bit of time on the back end of this, and you will see it's going to iterate a bit fast this year in design and some of the features. But the main thing is what you see now. There is a place to search for data, so you can go in actually today. Well, we can draw a box around Europe, for example, and you can add a search word like seagrass, and then you can also add searching in your private space. If we look at one of the, I was going to show. Let's redo this again. If we just look at one useful data set that's on the very top here, this is an example of other data that you might want to have together with your seagrass information. This is a global data set with marine protected areas, and I think I usually show it together with habitat data because it's often a good combo. Is my valuable habitat protected or not? So this is done by Protected Seas. We have made it available on the platform, and this is a medium-sized data set, or maybe even a small one. It has 20,000 rows, 87 columns with different information in it. And this is a vectorized data set, so essentially a shapefile, meaning a table with geometries like points, lines, or closed polygons. And so we have a unique sort of fast indexed way to store that kind of data, which means we can visualize it on maps. We can work with it in many different ways. The platform also holds raw files, so that could be documentation. Here, this is just a text file. We can watch it. We can download it. They could also be thousands and thousands of sonar data files or something else, and you can have file metadata and work with it in file format too. We are going to be adding a dedicated raster gridded controller as well. I expect that's happening not too far away, but it's tech, so it's hard to say exactly when, but during this year. And then we will have a similar support for rasters and gridded, which is going to be very good, I think. And anyway, we have let's get out of here and let's have a search for seagrass. So if we just look at what's in the catalog, specifically habitat data, we have put a little bit of effort in, and for this webinar, a bit of extra effort. And so we have some global data sets available. Of course, I should mention, these kind of open data is built on the back of giants. So it wouldn't be possible if it wasn't for all these great efforts that's been going on over time. And so there are many good ways to access those individual data sets. And for example, this is a global map hosted by WCMC with Seagrass. You heard about Allen Coral Atlas. They have a really excellent viewer of their very impressive data set on corals, but it also holds seagrass data, and you can download it and access it in their viewer and do many good things. Or EBONet data. There's many sources of well-served data, OBIS and other places. Now, I think we're bringing the platform is here. There's a chance to sort of aggregate large data like this and make it sync together. And there are other places that can do that too, but we're really trying to optimize here for speed and simplicity. Anyway, so we've done some of the work for you, and so we can go in. Let's have a look at, well, we can look at seagrasses in the United States from NOAA, for example. Then you can go in and we can go and explore that table. When you go into explore table, you're actually accessing, you're inside the data within the cloud. So we can now make filters. We can go, we can zoom in where I'm going to demo in just a little bit. We can draw a boundary box over our area of interest. We can filter on a specific class. And so this automatically happens when data is uploaded. We make this sort of pre-made statistics. Let's go with vascular vegetation. I hope that's right. Lina, shout if not. We can color it so you get some visuals as well. We can apply those filters and access those points. Now, anyway, so this way you can start exploring the data. There's a secret trick to override the limitation of 1,000 rows. Actually, you can actually load quite a lot of data this way. And what happens when you've done this? Sorry, the secret trick is to do that before you apply the filters. I forgot that. I forgot that in this morning as well. Let's do a smaller box. Okay, so actually, and when you've done that filtering, if you have a large data set that you want to, just access a portion of it, now you can actually export that data to an open source format. And this is open for anyone with an account, which is free. If you don't have an account, you only access the metadata. And then you can also grab this little code snippet. And so the platform is compatible with, it has a package to talk through Python and through R, which means you can read and write and do some operations from those languages. And so you can switch to, flick the switch here, copy and paste this code, and you will access that filtered part of the data set, for example, in our computer environment. Okay, so that's sort of what's in the open catalog. And so you can go here and maybe I'll show something else before we move on. Let's find WCMC. Okay, it's just another example. I should mention, so there's a unique identifier for every data set. That's how you connect to the data. That's how you find it. And so, if you find lots of good data, you can copy that ID and you can always find your way back. There are also two other boxes here, and this is helping you connect to this data through GIS. So whether or not your data is in your private space or in the public catalog, you can connect to it through OGC features, which is supported by QGIS and ArcGIS. And also a fairly new thing for us is offering this in vector tiles. And we will show you in a bit what that looks like. But essentially, this allows you to sort of stream the data into your work environment. Yeah, and at least for medium-sized data sets, that works fairly well. That was that. Okay, I think yeah. So if we head over to my data, we'll hand over to you in a second, Brian. Here you can create your own collections. And simply, the collection is simply just a frame, it's just a way to group data in a hard-coded way. When you have a collection, you can then add data sets. And here you can also manage who accesses this data. So yeah, let's hand over to Brian to show us a little bit of what it looks like to add your own data and what we have done sort of for this webinar. And we will share, well, we can copy and paste some links in the chat. At some point, you're going to get an email, hopefully next week, where we'll put all of these resources together so you can easily find them as well.
Yeah, thank you, Gustav, and thank you, Lina, for your presentations earlier. So as they both mentioned, it's like really helpful to be able to collect data, put them in the same spot, so that we can also like verify these mapping efforts, have multiple maps together. And so one of the ones that we want, or I'm going to show, is this seagrass spotter, because it's often like important to have these field data that might be getting updated over time. And so we get to have these like ground truth, but also ground sourced data sets. And so I'm just gonna quickly export this data set that has 10,000, approximately 10,500 locations points of where people have identified some species of seagrass. And so we're going to be able to come back and create a quick data collection or a data set within this data collection. And we're going to call this the Seagrass Sea Spotter. And then we're going to have it know that it's crowdsourced. And then we're going to call this Seagrass. We're going to just put a tag that it's global. And so then it's going to create this landing page for how to add our own data. We can drag and drop, so we can take this quickly downloaded data set, put it there, add any other associated files that we would want to do. Right now, it's not been uploaded, so we click this little icon, and it's relatively small, so it's pretty quick. So now it's uploaded, but there is no data table because it's not been ingested. So we're going to click this icon to the right to say to ingest the data table. If you accidentally uploaded the wrong one, you would just hit the trash can. And so now we get to see that the data table is there. If we come to the preview, we get to see these diagrams, but there's nothing going to be really visualized on the map yet. And that's partially because we need to identify which of these fields, because it's just a CSV. There's no geometry associated with like the actual file type. But we can come and edit that data table. And so you just click the field that you would want. And then for this one, we're going to say that the classification is going to be a latitude. It can also be a longitude, as we see here. And then that becomes longitude. Sometimes it's just a geometry field. And so you can mark it as that one as well. And so then we can come and upload this data table. And now these data have been ingested. And this is as a CSV. Our platform takes CSVs, GeoJSONs, and GeoParquets or Parquet files, but sometimes you get data that are from a different format. And so I'm going to show a different way of being able to ingest those data sets to sort of show how you can do it programmatically. So Marine Cadastre is like NOAA's ocean data hub. And so they have this seagrass layer that you can directly download. But it's also, I'm just going to come over to R quickly because that's how I want to show this programmatically. And I'm just going to quickly kind of walk through it. Is you can pull it from a link. You can also load it locally. And then I just make sure that we make sure that the geometries are valid. We can then transform it into the projection or the CRS that the Ocean Data Platform uses, which is WGS 84. And then we just reformat it for how the Ocean Data Platform likes the geometry fields. And then you're able to talk to the Ocean Data Platform through the R SDK, using a different landing page, and then you're able to update a table, push it. And so I'm just going to quickly come back and show that when this has been run, it takes a little bit because this is 1.17 gigs. It's about 1.1 million records, but you can, hopefully this will load, see all of the information here. And so it's a way of being able to pull from these other different data sources and then keep it localized, as Gustav mentioned, that like when you go to the WCMC, you're able to pull those data. And you go to the Allen Coral Atlas, you can pull the other data. And so these are just different ways of being able to talk to the Ocean Data Platform for uploading data. And so back to you, Gustav.
Give me one more second.
Okay. So one of the things, if I come back to sharing my screen, one of the we do have it so like you're able to add metadata and licenses and citations. And so often this is done manually. There is a way of doing this programmatically, and so that you can just like run sort of one script or update it sort of throughout, like copy and paste. So often I will copy this section of my code, and then when I'm using a different data set, I'll just copy and paste. And then you just change this landing page. And what's nice is that to build out the schema, you just have to put in the data. In the parlance of R, you just put the data frame back into here, and then the RSDK is able to build it out. You don't have to say, okay, this field is going to be an integer, while this other one is a string. And so it's quite nice to be able to have this so that you can update just running some lines of code. Gustav,
Thank you,
are you
Brian.
ready?
I just prepared our poll. Anyway,
Okay,
great.
thank you.
Everything's set to go. Okay, so with that, I just want to maybe just a comment of that a platform like ours, we're constantly trying to make it as painless as possible to get data in. But of course, good data management and data wrangling and so on always have to happen. So there are certain things that we can do on the platform side, and you will see a set of improvements like fixing broken geometries and things like that. But still, data science can get quite complex, and yeah, there are many ways to solve those problems. So what Brian has done, and me and Brian actually we collaborated on this data collection. So you can see here. Well, actually, Lina, I didn't add you. I will as well, and anyone else who want to join in. But me and Brian have collaborated, and Chris Rothsma was in here as well. And we added some different data sets that were not on the platform already. And then so we can go in them and we can explore them one by one and do what I did before. Yeah, for example, here you see also OBIS. OBIS have we have OBIS represented on the platform as well. It's a very large data set with 254 million rows, and I've done the filtering and I put just the seagrass data on here. But what we want to do next is, yeah, we actually want to bring some of this data together, and so let's see. I go into one of these data sets. This is how I manage it. Maybe I'm collaborating with somebody like Brian. Maybe we want to edit and work on the data. We can write new rows. We can do a ton of things in here, especially from the data science environment. But yeah, I want to now move on to bring the best available data together. And so we can hit the preview, which gets us to the place where we're exploring that one data set again. Now I'm going to click on Explore Map. Explore Map was just, well, this version of it was released just a couple of days ago. And what this is it is showing the data in what we call vector tiles. So if you think about, for example, Google Maps and you zoom out, you know that the rasters are, it's fast because you have different tile layers that have a coarser resolution at different zoom levels. Now, vector tiles is doing the same thing, but for vectorized data, which is commonly used, for example, in habitat maps and seagrass data sets and observations. Vector tiles can be a bit more complicated because vectors can be very complex, they can be simple, they can be very large, and so it's not a trivial thing to do it fast. So vector tiles is a standard. It's a standard that's not built by us. It's built by the global standard community. But the way we're implementing it is our backend. Great. So we have one data set, and we can see it also at the zoomed out level. This is still a beta mode, so there are some artifacts still showing up in this. We're working on that. But in this viewer, then we can go in and we can, for example, put the color on some column. It's inside that data. It could be continuous. It could be, in this case, the family of seagrass that you see. We can zoom in, for example, here in Puerto Rico. Give it a second, and you will see all of these OBIS observations. We can click on a point. We can see what goes on there. We can read about that data set. Okay, so that's fun, but we want to work with more than one data set, and now you can. So you can search the open catalog, you can search the private catalog, and so if we go seagrass, if we also enable the private space, we can start adding, a bunch of data from here. For example, what should we do? Maybe we add the Alan Corlett. It's actually quite challenging. Maybe we want to add that data set with MPAs. Protected seas. Let's add that. We can see some of the reserves, and so on it goes. And then we give it a second. We can decide what are we focusing on. Alan Corlett has coral reefs. I actually want to get rid of those, so we can do that too. And maybe we want to color the MPAs on something specific. And give it a second, and it will load. And when you've created a view like this that you like, you can copy and paste this link on the top, and it will show the viewers exactly what you see, as long as they're signed into the platform. I did a little bit of work on that to bring in some more data sets. So if we spin around the globe a bit, we have started to bring quite a lot of seagrass data together. And if you zoom in, for example, then to this region in Puerto Rico, you can see there are many maps and many data sets. If I wait a few more seconds, we'll see more data show up here. Good, but I'm a planner, and I just want to have a map tomorrow for our planning activities. Maybe I just want to use, available global layers like WCMC. Okay, you can do that. But if you really want to use the best available data without going into, the really hard work of creating these maps in the first place, you might want to join all of these different data sources. But that is actually not that trivial, especially not at a large, more of a regional global scale. Now we have some compute functionality on the platform, and I will show you that in the next 5 minutes, sort of what this kind of platform can already do, and you can maybe then fast forward a bit into the future with AI and more speed and so on, and you can see where it's going. So with the platform, the data that sits here, you can read it, you can write to it, but you can also do some functions on the server side. And One that's particularly useful is something we used when we created this early prototype. This is over a year ago. We were aggregating habitat information. Let's zoom over to the same area from some of these global sources, with the thought in mind of management unit scale of habitats and bringing together lots and lots of data. So this is just a seagrass. We could switch on the coral reef, an example of that too. This is using Mapbox tiling in this early version, and we use hexagons. So these ones are developed by Uber. They cover the whole globe, and we aggregated them, all the data that we can find. Is there a seagrass in this hexagon or is there not? And we built this. So how did we do that? Well, first of all, this kind of view, now you can generate that. And I know the colors are a bit powerful, put it that way, on the current implementation, but we can go in here and change. And so if we look at seagrass as an example, this is the same data set. It's openly available on the platform. You can play with it. I mean, I could even give you it in the chat right now if I manage to find the chat window. Be brave and try it. And so those of you who already signed in can click that link and see the same view as I just showed you. Okay, good. So, and then we can start visualizing this the way we want it to. We can bring in other data. Maybe we want to bring in the protected seas data set, put that on top, and so on. But I actually want to create this map. I'm not happy with this map. I think it has too few layers and it's too coarse for me. Okay, we head over to the documentation. Here you can sort of see the full scope of what you can currently do on the platform. There is a kind of a nice scroll through and get some of the main features laid out for you in the intro. And then you can go all the way down to those data savvy of you who like coding. And here you can see how you're talking in Python and R with the platform. Those who are into GIS, this is where you find the documentation about connecting to GIS and so on. But a nice thing today, if you're not that that code person, but you still want to do these things using code, the AI assisted coding is going so quickly forward. Just as an example, when I prepared to this webinar with too little time, I loaded this documentation together actually with some pre-made skills that helps the AI understand how to talk and do things with the platform that my colleague Joe did. Here's an example of that. And I ran Claude Code to help me both ingest data and do some of these operations. So just for those that haven't done that, really you can, as long as you understand data and its limitations, you can already get quite a lot done. Now, if you hit this workspace button, what happens is we're spinning up our Jupyter Lab environment. Actually, let's just close this for a second. And what you'll see is that you can choose to open an R notebook, a Python notebook, and something called JGIS, which allows some JS functionality here in the cloud environment. And yeah, it can be quite useful to be able to work with the flexibility of open source toolings and a compute environment next to the platform. Okay, so I've already sort of started this space for us to save us a little bit of time. So yeah, what I'm doing here is I'm again connecting to the platform. I'm putting in my API key. All of you that have created a user will easily find it in the top right under your user. You create a key and then you can connect from anywhere. The workspaces are actually pre-authenticated, but I recommend using the key anyways because then they stay open longer. I started this line of code starts the GIS project and put some background map behind it. I decided on the boundary box for my sort of pilot area today. I'm looking at the Caribbean, and I'm looking at a small little patch of sorry, what did I do here? Let's remove these. A small patch of the Caribbean to get a first glimpse. And then I'm adding. I'm just talking through this now to save us some time because we'll be done in a few minutes. Anyway, so I'm taking these IDs. I'm filtering, and we can run them if we want. I'm filtering this data, and I can bring it into my environment. Here I cropped it. The Allen Coral Atlas has 40 million polygons. It's a challenge anywhere to bring all of that data in and away from somewhere. But I'm just cropping it, so the platform just gives me what I'm asking for, and I'm also filtering to get seagrass. And then, for example, I can add it to this map here. I think what I already had, now it showed up. So here we can see an example of a polygon now in my preferred environment, which happen to be our workspaces. And I can add then, many other data sets. Like here's the WCMC data. I'm a bit more brave. I'm cropping it on the regional area because it's not as large, and I can add that. But we are now moving data, and moving data comes with a cost. And if we did this at some other scale, this is actually maybe not ideal. It works here, but at some point it's gonna, be limited. Now, I mean, that's, for example, why you have these vector tiles on the platform to quickly work with really large data. But, I keep working here. I've added, for example, the NOAA National Seagrass layer. I'm filtering that based on, in this case, within my area. And you can keep doing this for many data sets. This is the local data set in Puerto Rico. And what else did I add? I added the OBIS observations. These are not trivial. It's about 2 million points. I added EMONET. Well, this was done today, Lina, to your benefit after the webinar. But I'm actually on purpose not showing these in the map now because, yeah, it comes to a cost. And then I'm running a piece of code that you don't need to necessarily follow along with, but I'm essentially, if we scroll down a little bit, what I'm going to be doing next is to take all of these different sources and I will aggregate them on these hexagons. And so the interesting part to take away in this very short time is we can run this operation now on the server side of Hub Ocean, which means you're not dependent on the bandwidth or the size of your compute environment. And so I've added a number of sources. I've filtered them to grab the data I want. I explore them on the Ocean Data platform, or I could explore them in my compute environment. But I did that work to filter and sort and decide what is it I want. And now I have all of the, spatial data that I want to combine. And so we're doing a simple operations to say, is there seagrass in my hexagon of the resolution I choose, or is there not? And what are the source? And so it's always wise to do a pilot, and I did the regional, and I have a global map running. And so we actually ran this as a pilot. Maybe I dare to even do it live. Let's see if that works. And so I'm now running this aggregation feature. This is not trivial compute if you do it on really large data. And you'll see Allen Coral Atlas ran in a few seconds, WCMC even faster, OBIS, EMONET. Yeah, so we're capturing the polygons and we plotted them on the map. I believe, did I do that step properly? Let's see. Okay, yeah. So here you can see the hexagons that we generated. Check that worked. Anyway, we'll spin over to see this in a second. and then you can push them to your data set on ODP. I did this regionally, and I did this globally. Last night, running this globally took about 4 hours, and I added a few data on top of that after the webinar today to add a few more data sets. And we're running a bit short on time, so we'll skip over to what that looks like. Now, this is the, a show of these results we generated for these webinars, and I'll share this with you at some point so you can explore yourself. But this is my pilot, my regional, and my global maps. They have a few different resolutions. But what I'm showing here is, for example, all of these hexagons are saying there's seagrass there, and so I choose to visualize what the source of that was. So here you can see who says there's seagrass there. Well, IMONET, NOAA, and WCMC does. I know that IMONET have actually grabbed the NOAA data sets, so that's the reason why IMONET says there's coral there, and so on. But in some cases, maybe there is a lower quality data set, and you know that you want to filter that out. And I think we have grabbed OBIS observations and all sorts in here. And so actually we did this. We generate all of these outputs, and now I created a copy of the global, just to safeguard a little bit the global co-creation demo. And so what we can do here is we can keep adding. I can add other collaborators to this data set, and you can write more data into it. That means that you could potentially have sensitive data in your My data set that's not possible to have in a sort of the proper fair way, but you still want to contribute to this management scale product, and you're okay with the licenses and whatever else that goes into that specific map. Let's see if did I prepare that? Okay. No, let's look at it directly here. And okay, so what do we see? Give this a second. Maybe we'll add the MPAs as well, because that's nice. And let's make those a bit transparent so we're not taking over. So now we can go in here and really explore this data set, and we can work with, it's not showing yet because it needs to load for a second, but what we have now created an aggregated map that can be discussed, that can be improved upon, and that can be potentially used by managers as well. Okay, with that, I think I covered, this is the same example with some of the outputs. Again, I've shown that. With that, I think I covered the brunt of the demo. Hopefully I didn't forget anything super duper important, and hopefully you got a bit of feel to what can be done. I see we have some good interactions and chats. That's great. Before we open the mic for questions, I'm just going to start a quick poll, and it's just 3 questions. It'll be over quite quickly, and we much appreciate if you join in. The first one is just your quick feedback on how you thought this webinar was. Too fast, too complex, confusing, or fun. Just put whatever comes first to mind. And we'll give that. It stays open in the it stays open for a few minutes, and you can keep adding answers here if you want. And we know these webinars are a bit filled with information. Again, I hope that still comes across as useful, and that you can come back and ask us more questions and take part of other ways of knowing more about the platform. Great, I see we have some responses. Thanks for that. And I will actually move over to the next one in the interest of time. Apologize, we're going to run a few minutes over for those that can stay. Which part of the live demo webinar were most relevant to your work? And so is it sort of consuming data in this kind of environment in the Ocean Data Platform? Is it managing your own data sets, sharing and collaborating with those who you choose? Or is it the analysis part, or all of above? So multi-choice. You're very quick to respond. Thanks for that. Maybe it's because of interest of time. And we see a lot here interested to consume data. And so that's the majority of you interested in sort of easy access to data. But some also in the data analysis side. And then the last question, I promise. Yeah, we are keen to collaborate to make more seagrass data actionable, as well as other ocean data. Which of the following applies to you? You have ideas for more seagrass data that could be useful for everyone? Please reach out to us or have a go at putting it in on the platform yourself. Are you interested to join future collaborative efforts, for example, on developing seagrass maps? Would you like to use those kind of products that I sort of teased today in your own work? Or are you more interested, or are you interested to have access to underlying data for those maps? And again, multi-choice, you can pick all or nothing. Okay, while you think about that, I'm checking the chat again. So again, apologies we're going over time for a few minutes, but for those that can stay, appreciate it, and I'll keep the call open for at least 5 more so we can have some questions. Lina, over to you.
Yeah, so when I was preparing my talk, the reason I focused on publishing data, I mean, that is really the key. I mean, you see what cool things you can do, but it means we as a community, a seagrass community, and people doing seagrass monitoring, it's really about publishing the data, because if we do that, we can really do cool stuff. So I think we really need to change the trend and become much better at publishing data and really celebrate those people that publish raw data, because I think that is the most valuable thing, right? Because you can do so many things with it.
Yes.
So that's my words of advice.
I mean,
I will definitely
I would give
celebrate anyone.
Yeah, what we want to achieve on the platform is, I mean, we're very careful to ensure we attribute, of course, all of the hard work for those that are publishing the data. So that's number one, most important, to give all that deserves credits, and to handle data in that way. The other one is, I think that, you know, not all data can be shared as much as we want it to be. And so the intention of the platform is to be creative and to provide tools and mechanisms in the more messy world, right? I think this is where it sort of maybe adds on or adds, you know, some additional options to that, you know, complete open community. And that's, I think, is to, because then you're leading people into the way of thinking of sharing data. But maybe it starts with just having it possible to share, or sharing with a friend, or such. So I think that's what we are trying to do here, and when we talk about the My Data space. Yeah, so that's maybe my comment back on that. I fully agree, but I think it's great to have tools for the real world, and there can be many reasons why things can be sensitive. You know, for Sweden, for example, Lina, that not even all data can easily be shared for military restrictions and other things like that. Or there could be a moratorium on data for publishing for a few years, but maybe it still should be in the Marine Spatial Plan, and then this could be a mechanism. Okay, anybody want to voice their questions in the chat? I see, Brian, you've been active. That's very good. Then please unmute and make yourself heard. Brian, is there anything that you want to say from these
I was
questions?
gonna ask Elizabeth if she would like to see sort of the difference between private and public data, and maybe Gustav, we could just show it for anyone who's still on. That was a major question of just trying to understand of when you toggle private search within private data, what does that mean? And so maybe we show how we manage data to be public and private. So would
Yeah.
you want to take
I,
this, or do you want me?
I can do that. I
Okay,
can do it again.
thanks.
Okay, so right, if we go into your data space, when you created a data set here and you click manage access, you're the only one that have access to this data. We cannot see it either. And so you're in control of that data. And the way that you currently can share is you can add other users, and you can also add groups as admins, editors, or viewers. And so, I have some collaboration right now. We have a training with 50 people in the West Indian Ocean. So we have all of these groups set up to share within that group, and let's share with them. They're more than welcome to. And so I can click here on the sharing on my group number, bio everyone. Great. We'll add in them. So now they can see this being shared with them. There is also an open link, and the way this open link works is it just means that the data it's not listed, but actually this link is now open for all of you. So you can already go in now and see that. And if you're not signed in, you will see the metadata still, but you cannot download the data for that. You just need to have that account. And the difference then with the data in the catalog is that then we have, and you can then request to publish. The main thing that happens is once that has been approved, and it's not about data quality necessarily, it's about metadata quality, ensuring that we have the rights to publish it and that it's responsibly made essentially. Then it goes into the catalog where it's listed. And speaking of FAIR, then all of these datasets have a JSON LD file that gets picked up by Google and others, and Ocean Info Hub can pick it up as well. And so now this data can be searchable from other platforms. And yeah, so that's the main difference. I hope that made sense. Stephen, please go ahead.
Cool. Yes. So what you just said, the demo today, and then what you were just talking about made me think about one of the collaboration barriers I've encountered before with ArcGIS Online is, trying to work across different licenses and different organizations. And I see that as being something that perhaps the ODP could solve, except for it looks like the Hub Ocean Directory sign-in is Microsoft based. So I'm curious if you think it would be possible to add ORCID and/or other authentication mechanisms, because in fact, ORCID is the only one I know of that's allowed in all countries where you might collaborate, whereas like Google, GitHub, Microsoft, they all have certain places where they're blacked out.
Yeah, very good comment. So now we're a little more into the details, which is good. So orc IDs as well as now I'm mixing up, Stephen. Which one is for people and which one is for organizations?
ORCIDs for people, RORs for organizations.
Right. So, and I should also mention we do have ability to generate DOIs, digital object identifiers on the platform, and so there's we're strengthening the metadata side as much as we can. Yeah, so that's one.
But sorry, my question wasn't about the metadata as much as just about the ability to collaborate. So for example, when I was at USGS, we struggled to share spaces with NOAA because we had separate Esri licenses. So, but it seems like this is a place where we could do that more easily, except it requires the management of another email address and password. So I'm curious if you could add that authentication where you wouldn't have to then manage another profile.
Yeah, I think that's a very good suggestion. So I just brought up together with metadata because when we talked a bit about with DataSite, they also use these IDs as well. So it's something we're looking into how we can get organizations and people to use these two mechanisms. So very good input, and there will be a lot more coming when it comes to managing more organizations and projects and so on. The platform is I would say a bit basic at this point on all of the different ways you want to collaborate, and the same thing when, you know, if you publish a data set, or if I publish it, or HubOcean does, the original publisher versus somebody who's just publishing open data for somebody else. There are many flavors to consider, and what we're trying to create is just a system where there are as many simple ways to bring as much data together as we can, while respecting, you know, all of the all of the people and laws and so on. So it is a bit complex to do that really well, and we much appreciate the community to give us input and help, and you have already done that, and we're looking forward to get more input of the kind. Thank you so much. Okay, I dragged quite a bit over time, but thank you for so many for staying. For those that couldn't stay, hope you find this recording. I will make a send out also with some of the resources. And just thank you so much for showing up, for having questions, and hope to see you in some other form and shape sometime soon again.
Yeah, please feel free to email either Gustav or I, and also thank you, Lina, for talking or presenting about the EOV at the beginning part.
Yes, thank you so much, Lina. Thanks for reminding me, Brian. Very great to have you here. Thanks so much.
Well, thanks,
It was a pleasure to be here. So thank you so much for the invitation, and good luck. And I mean, just when we started planning this and the number of data that is there now, I mean, it's amazing what happens just in a short amount of time as well, and new functions and features that you have. It's really cool.
If you knew how much happened last night, you would be surprised.
Yeah, but that's also that's also cool.
Yeah, no,
so thank you so much, and thanks to everyone that attended also.
Great.
And my Seagrass friend that also been here.
I think we have many Seagrass friends here. Who can't love Seagrass? I'm a big fan of Seagrass, Lina, if I didn't mention that.
Yeah, I know. Thank you, everyone.
Bye-bye.